Good evening, young people. I just want to talk to you a little bit about scientific notation. You'll notice that these numbers are all in scientific notation. You can see the notation right over here. This is the form of scientific notation. These numbers are very large or very small numbers that we tend to use a lot in science class. And when they're seen normally, they look very different. So let's look at that. In science, we deal with some very large numbers, like this number, 6.020000000000000000000000000000000. And every time you have to do a calculation, you have to write out all of those zeros or type them in the calculator. And sometimes we deal with very small numbers, like the mass of an electron. And I'm not even going to say all those zeros, okay? So how do we deal with that? If we're calculating in the mass of 1 mole of electrons, that's going to be a complicated calculation. Look at this calculation right here. So this is the calculation for the mass of 1 mole of electrons. That's a lot of zeros to plug into that calculator, and a lot of mistakes are going to be made. So how do we deal with it? We turn things into scientific notation. So the one thing that we have to remember is they have to be the same number. So it has to be the same number. So it has to technically be the same value, okay? It also has to have the same significance. The reason that is because remember, significance is determined by its measuring tool. And if you're changing significance, you're changing the measuring tool. So we put it in a format of m times n to the 10. And what this literally means is that we're multiplying 10 times 10 times 10 times 10 times 10. How many ever times n is equal to? Okay? If n happens to be negative n, then what we're doing is we're dividing by 10, by 10, by 10. And dividing by 10 also means this is the same as saying that we're multiplying by 1 over 10. So these two facts are the same thing. So when n is negative, this is what is happening. When n is positive, this is what is happening. Okay? M has to be a number that's between 1 and 9.99. So in other words, I can only have one digit to the left of the decimal point for it to be in proper scientific notation. And n is the number of places I have to move, the number of tens I'm multiplying by. And basically, it's moving places. So let's look. So I have this number. I can see that the first time is I'm going to insert a decimal point if there's not one inserted. So I see that a decimal point goes right here at the end. Then I'm going to start and decide where the decimal point must end up. Now I know I need a number with only one digit to the left of the decimal point, so I need to go right here. This is where I would like to go because that means there's a 2, just only a 2 to the left of the decimal point. So I do that. I move my decimal point to there. So now I count how many places I need to bounce that decimal point. So I bounce it 1, 2, 3, 4, 5, 6, 7, 8, 9. I bounce it 9 places to get between the 2 and the 5. Now I'm going to rewrite it in the form of m times n to the 10, where n is equal to the number of places I bounced, because that's the number of tens I need to multiply my new number by to get the value of this number, okay? So I'm going to rewrite it as 2.5 times 10 to the 9th. 2.5 times 10 to the 9th. That means 2.5 times 10 times 10 times 10 times 10, times 10, that's 5, 6, 7, 8, 9. That's literally what this means, okay? And so eventually this will have the same value as the number that we saw in the previous slide. It will have the same value as this number right here, okay? So the exponent is the number of places we move the decimal. All right, so here's another example. Let's try it. So decide where the decimal must end up. Remember, I have to have one number to the left. Yeah, it's going to go between the 5 and the 7. Good. So now I need to count the number of places I need to bounce the decimal. I go 1, 2, 3, 4, 5 places to get that decimal where it belongs. Now I'm going to rewrite in the form of m times n to the 10, but notice I went a different direction. Because it's a decimal number, I'm not multiplying by 10, I'm actually dividing by 10. So I have to change it to a negative. So my answer is 5.79 times 10 to the negative 5th. Okay, this exponent is negative because we started with a number that was less than 1, and so I was dividing by 10 and not multiplying by 10 to get that number. Performing calculations in scientific notation could not be easier. Addition and subtraction, all you have to remember is that you have to have m times 10 to the n, and the 10 to the n must be the same. So when you add or subtract, you must have 10 to the n, and we have to change everything to the same n. Okay? So once again, we know all that information. So notice my 10 to the, they're the same. And because they're the same, I can now add these two numbers. If these two were not the same, I could not add them. I would have to get them the same first. So 4 plus 3 is 7. Okay? And then I just bring down the times 10 to the 6. That's all I do. So let's try one. 4 times 10 to the 6 minus 3. Well, that's just 1 times 10 to the 6th. It's easy. So here we go. We've got one that's a little different. Notice what's going on. The exponents are not the same. So you have to make them the same because the decimal points have to line up. These two numbers' decimal points do not line up. So the first thing I need to do is change them. So here I go, move the decimal point on the smaller number. I move it from the smaller to the bigger. So I do that. So the 3 moves over, it becomes these two numbers. Now I can add them together. I get 4.3 times 10 to the 6th. I'm doing the same exact process, but notice I had to change the 5 to the 6. I have to do that. And to do that, I've got to move my decimal place over one more place and take it out of proper scientific notation to align the decimal points together and be able to add those numbers correctly. So that's addition and subtraction. So here you go, problem for you. Go ahead and stop the video if you need to solve. Okay, there's the solution to the problem. Okay, multiplication and division. Multiplication, first of all, remember we still have the same number. So we multiply the m's and then add the n's. So any m's we have, we multiply them and then we add n's together. So here we go. So we're going to multiply these two numbers. 2 times 4 is 8. And then we add the 8 and the 3. 8 plus 3 is 11. 8 times 10 to the 11th. Pretty simple. Okay, you try a problem. What are we going to do? Okay, division. Scientific notation. So expresses a number form. In division, it's the same thing except we're going to divide the m's and subtract the n's. So let's look at that. So here we go. We have 6 divided by 3. We know that that is 2. And then we have times 10 to the, and we subtract 9 minus 4, so times 10 to the 5th. So we get 2 times 10 to the 5th. There we go. So problem for you to try. All right, that's the end of our show. Thank you very much.